Alright guys, moving on to numbers 4 and 5. 4 and 5 have kind of a lot of parts to them. I'm going to get kind of right to the main idea. For numbers 4 and 5, they ask us to use the equation they gave us to predict how much we would expect a 63-inch person to weigh. First I want to look at this equation a little better. This is the equation they gave us. The predicted height was equal to 186.5 plus 4.7. I'm sorry, the predicted weight, my bad. It's 186.5 plus 4.7 times the height. There's multiplication going on here, so times the height. And so another way we can write this is we can write this as y with a little thing on top equals 186.5 plus 4.7 x. X is the height, so we know what the height is. And the reason why y has a little thing on top is because if we're going to solve this, and we're going to put in a number 63 in here. We're going to try to use this to come up with the height of a weight of a 63-inch person. If we put 63 in here, the number we get is not going to be one of the original dots we had, because we didn't have anybody who was 63 inches tall. So we're going to get some other dot, some predicted dot. And so a dot that wasn't in the original data. That's why this y has a little thing on it. And literally they call it a hat. So you would pronounce this y hat. So this is called y hat, one of the funniest ways to describe a variable. But yeah, so y hat equals 186.5 plus 4.7 x. So what we're going to do is we're going to use this to predict how much a 63-inch person would weigh. So we're going to say, okay, so when x is 63. If x is 63, what do we do? Well, we're going to plug it in. So y hat equals 186.5 plus 4.7 times 63. So what's going to happen is we're going to plug in 63 in for the height, and then we're going to do all the math, and hopefully we're going to end up with a predicted weight. And it looks like I messed up, and there's supposed to be a little minus sign here. So minus sign here. There we go. That makes a little bit more sense, huh? So minus here and minus here. Okay, so we're going to do, this is going to be equals negative 186.5 plus, what's the math here, 4.7 times 63 looks like 296.1, and then we do the math here. I'll just subtract 186.5 and I get 109.6. So if we had a person who was 63 inches tall, using our equation here, we could predict that they would be 109.6 inches tall. Let's go ahead, or they would weigh 109.6 pounds. Let's go ahead and put that point on here as a predicted point. So 63 inches tall, and they were 109.6, so really close to 110. So we'll just put it right here. I'll mark it with an X to say that's our predicted point. All right, so we predicted right there. For number 6, they ask us to predict, well, what if a person was 67 inches tall? We can do it the exact same way. X equals 67. So same exact thing. So y hat equals negative 186.5 plus 4.7 times 67. Let's do the math real fast. Negative 186.5 plus, okay, 4.7 times 67 this time. And we get 314.9. And then we'll subtract the 186.5. And that's 128.4. Okay, so now if a person is 67 inches tall, we can predict that they're 128.4, or that they weigh 128.4 pounds. So let's put that on here too. So 67 and 128.4. That would be right about here. So we'll mark that one with an X also. Now notice there were other people that were 67 inches tall that were not 128.4 pounds. But that's what we use that's what we get when we use our formula. Formula is an approximation. It's the best guess, taking into account all the other data. Now something interesting we can do now that we have these two predicted points is we can use that to draw the line of best fit. And I'm going to use the lid of my calculator here as a straight edge. But all we got to do is, these 2 points that we predicted are on that line. So we can just connect these two points. So we'll go right here and right here. and this will be our line. I know they've already kind of drawn it for us, but we can use this to kind of draw it, kind of haphazardly draw our own version of it. There it is. Okay, so there's our line. It goes. We know it goes through those 2 points because we use the equation to get those 2 points. So that's how we know that those 2 points are on the line. And so there's all the points and that the actual drawing of the line. Kind of a nifty thing, and you can kind of see again, kind of reinforcing what we had before. It would be unreasonable to have a point way up here. It's really far away from the line. Really, the idea is we should be pretty close to this line that kind of runs down the middle of all the data. All right, good deal.